Today we're talking about the decomposition of the group 2 carbonates and the trends you can identify as you go down the group. So the general trend is as we go down the group 2 carbonates get more stable. What I mean by this is that the temperature required for, suppose, calcium carbonate will be higher than magnesium carbonate. So the temperature required for these carbonates as you go down the group to decompose will be greater. So let's go into why this happens. So let's take magnesium for example. Magnesium has 3 shells of electrons, whereas calcium will have 4. So if we draw a little diagram, let's just say this is magnesium. We got our first shell, the second shell, the third shell. Okay, and now we know that metal carbonates are ionically bonded. So we know this will have a charge of 2+, and this will be ionically bonded to a carbonate with a charge of 2-. So in calcium, this will look pretty similar, except that we have 1, 2, 3. Sorry, this is a pretty bad drawing. 1, 2, 3, and then 4 shells, and then also attracted to our carbonate ion. So the difference between these two is that we have a different distance from the positive nucleus to the outer electrons, and therefore also the carbonate ion. So because the magnesium ion will have a smaller ionic radius, it can polarize, kind of attract with its electrostatic force of attraction between the positive nucleus and the negative carbonate ion. It can attract it more. And what this causes, it makes this individual CO bonds in the carbonate weaker. So this means that magnesium carbonate can decompose at lower temperatures. Whereas in calcium, this distance is much greater, okay? So we have lower forces of attraction. So the CO bonds, yes, they're weakened, but not to the extent at which they're weakened by magnesium. So because of this, calcium carbonate will decompose, however, at slightly higher temperatures as compared to magnesium carbonate. Now let's talk about what they form. So it's pretty simple to remember. We just have the metal carbonate, MgCO3, and this thermally decomposes just to the metal oxide and carbon dioxide. So let's try this for calcium. Similar concept. It's not too hard, and I will probably be making my next video about the decomposition of the nitrates. However, just let me know if you want to see anything else. And sorry I haven't uploaded in a while. I've just been really busy with exams and stuff, and yeah, I know the energy of today's video is a bit down, but it's because I'm really tired right now. But hopefully in the next video I'll be coming back with more energy. Thank you so much, guys.